And moving to our next session, we're now talking about building carbon neutral cities. So sustainable building is one of the most important levers to reduce carbon emissions. But what do the buildings of the future look like, and how can we make cities more sustainable? To answer that question, we have two professors. The first is Ursula Eicker, the Canada Excellence Research Chair for Smart, Sustainable and Resilient Cities and Communities at Concordia University in Montreal. Ursula has held leadership positions at the Stuttgart University of Applied Scientists and its Centre for Sustainable Energy Technologies. Since June 2019, she leads a research program that receives 20 million Canadian dollars in funding to establish transformation strategies towards zero carbon cities. And Ursula will now tell us a little bit more about this project. Thank you for joining us.
All right. Thank you for having me. This morning we introduce quickly ourselves with some short presentations, and then hopefully we have an interesting discussion. I mean, since joining here 2 years ago, I spent the first 2 years basically to find out who is working on city-related topics and how to bring this very broad field of transformation together in one institute. And we just founded this Next Generation Cities Institute, which contains researchers, about 200 faculty members in 3 clusters on built in natural environments, on mobile, secure and sharing cities, more as a sort of software part. And then we have a big design, arts, culture community, research community here at Concordia that deal more with the experience of the city. So because I think I'm very convinced that we need this whole spectrum to make transformation happening. And I think we have now the people to bring this all together. But I want to show you a bit the situation here in Montreal and in the first project that we worked on to transform the city to more eco-district qualities. And if you think about eco-districts here in the Canadian context, mostly people talk about greening, urban farming, food access, waste management maybe, and transportation. And nobody seems to talk about buildings. And actually the reason, if you look at the sort of Montreal carbon footprint here, is you basically don't see housing in the carbon footprint, which is very unusual compared to other provinces in Western Canada, like Regina, Saskatoon or so, where housing plays a big role. And that is due to the pretty peculiar fact that Quebec has basically 100% green electricity grid, mainly from hydropower, and most of the heating and cooling is done with electricity. So, but of course, transportation has a major carbon footprint, and as everybody wants to electrify transport, I think building efficiency is still a big deal here, because of course we don't have the capacity to electrify transportation if we don't liberate the energy elsewhere. So when we work on sort of district case studies, and there's a lot of old industrial settings here in Montreal that get redone, and so we talk, of course, on the building sector, or basically on the full spectrum of problems. I mean, how to create net zero buildings, integrate local renewables. Montreal has very ambitious zero waste concepts, but we are very far off it. And then there's this whole mobility topic and biodiversity and inclusion. So lots of topics that you need to tackle if we talk about such a district development. And there's many players involved. So what we do as a university partner in these projects, we come up with digital twin strategies. So my whole team of 50 graduate students now work on developing tools to model these transformation scenarios, and then also provide operational strategies. So we develop an open source modeling platform called Insel for Cities. And the first step is always to come up with geometry scenarios to basically model a district densification or new development. And then once we've got a few geometry scenarios, we have a full workflow to calculate heating demand of every, and cooling, of course, of every individual building, and then do different scenarios for window to wall ratios, insulation standards, and so on. And of course, renewable integration into such districts. So we model the photovoltaic potential, for example, and depending, of course, on density, you can cover 100% if it's a low-rise development, but here we focus really on more, at least medium density to high density developments, and then the local renewable fraction goes down, of course, so to maybe 30 to 50%. And then we look at the energy systems, including comparisons of central versus more decentral solutions in the building complexes, so including the distribution network modeling. So here we recommended geothermal heat pumps for the system. And yeah, I don't have time to go into the detail. This is just a very short overview. And then we look at the other contributions from waste, which should be reduced, or wastewater, which is always there. And if you look at the district here in the southwest of Montreal, there's only one central wastewater treatment plant, which is located on the other end of the island, and it means actually pumping the whole sewage waste 30 kilometers. So in that case, we're looking for local wastewater to energy solutions using anaerobic digestion, and that could contribute another 5% to the demand of that district. So on the whole, with this platform approach, we try to model the integrated concept of energy, transportation, waste. And if I just summarize quickly the main lessons learned from these kind of analysis, it's, of course, if you build compact geometries, you can bring demand down by, in that case, by up to 30%. But still, insulation standards and the building efficiency standards is the most influential factor that can triple heating or cooling demand. So it's much more important to get the building efficiency right, and the building codes here leave to be desired, let's say. And then you can really come up with 10 times lower, in that case, electricity demand, because we went for the heat pump solutions, and we can cover half of that with solar photovoltaics to increase resilience. And at the same time, these sort of high density developments, of course, improve the walkability and access to public transit, and thus reduce transportation related emission. And maybe to finish off, the lessons more on the sort of regulation side. How do you make that happen? This is not municipal owned land, it's privately owned land. So there's a limit what the city can really do. And the main instrument, I think, that works for creating higher than legal standards is the zoning process. So if you want to get ecological standards going, you need, the main instrument is basically giving the developers more density, because that means they can create more profit, and then they can invest into higher building standards or affordable housing and so on. So that's the main lesson learned from that particular case study, that the process of before the building starts is crucial to set these standards, if it's not municipally owned ground. And then the digital twins, I think, are a very interesting option to support this planning process. All right, that was a very short contribution from my side.
Thank you very much, Ursula. Very interesting, and looking forward to unpack a few of those ideas in the discussion at the end of the session. First, we'll hear from Elisabeth Beusker, who is a professor for real estate project development at the University of Aachen. Prior to that, she completed her PhD at the University of Stuttgart. Between her PhD and her occupancy in Aachen, she spent 2 years at BMW working in the division for real estate and facility management. Elisabeth, the floor is yours.
Now you can hear me. Thank you very much, Greta, for your introduction. Actually, I can just go ahead with Ursula Eicker's presentation because we are having the same view on the buildings and the urban district planning. So I just continue. There are 3 interesting numbers which the planners always have to have in mind if they make a real estate development or a building planning. It regards the energy consumption, the resource consumption, and the waste, what we kind of produce by every construction project. So around 40% of the energy consumption we relate to the heating and during the operation time from our buildings. 50% of the resource consumption is related to the construction sector, and the third number is kind of more than 50%, around 60% of waste is generated by renovations and demolition. What we have to have in mind by that is that right now we are thinking a lot about new plannings and new developments regarding the next 5 or 10 years, and we have a big lie because we say, well, the planners in the future, they have to make a good planning and have to be responsible for the buildings which we build right now in a standardized way. And that's actually a big lie. We have to start now with a better resource management and a better thinking how we deal with the waste, what we produce right now in the construction industry. And right now we are not doing it. We're just saying, okay, we make everything like we do or have done the last 20 years, and the planners in the future, they have to take care about the waste. And that's not the way how we should do it now. So the European Green Deal gives us a big target for 2550. First is related to new technologies, and this is we have to decarbonize the cooling and energy supply. So actually, I would say I'm not responsible for that part. But the second one is important. Energy and resource efficient buildings and cities. This is something what we have to have a better focus on. Of course, by integrating new technologies and new standards, let's say. Okay, the first lie I have already mentioned. This is that the planners in the future have to make a better job that we are doing right now. This is the first lie. And the second lie I would say is that we, at the beginning in the real estate development project, when we think about what is the scope, what is the use, what does the investor would like to have, we are always thinking in buildings, which is not the best way. We should think about in space and perhaps also in space which is already available. So I would say the first target of reduction of carbon emissions in the building sector is to think always about a minimization of spaces and volumes. So the question is, do we need the space? What are the best synergies we could create between different functions? Can we hire space temporarily? Something like that. So it's just about the first question. And then the second and third questions is about how can we build sustainable buildings and how can we develop sustainable urban districts and cities. Regarding the buildings, I just would like to mention that quite often we are thinking about new projects and also the standards and the regulations which we have to the funding regulations which we have for several buildings. They are always related to new buildings, and this is we have to change in future that we get much more power and money to refurbish the existing buildings, because this is a huge amount of our building stock. Okay. Normally, in normal construction projects, we would take the top-down approach. So we think about, we have an overview about the standards and regulation, how we have to build, what is allowed to build. We have our specific user for whom we build, and then we make a specific building planning for a specific site. And what we are doing in Living Labs is actually the other way around. So we say, we would like to change regulations and standards. We would do it with people, so we make a big participation part in the project, and we start with real projects to trying to tend to change something in the building process. This is the one living lab I would like to present today. It is called Smart Quad. It's running from 2020 to 24, so around 5 years. And a lot of people and stakeholders and companies are included into this project. And what is the core as a core target is we have 3 urban districts. It is a living area, it is an industrial area, and it is a very dense urban area. And we are implementing different technologies to reduce energy and to build them very resource efficient. This is our overall target. And right now we are kind of developing and planning these 3 quarters. And at the end, we also would like to measure the operation numbers and to make a monitoring. What's very interesting, I think also Mrs. Eicker has mentioned it, what's very interesting in the Living Lab is that we can analyze the potentials in the specific living lab, so on site, but on the other way, we can evaluate the potentials for a possible rollout in Germany or further than. So this is kind of 2 methods what we apply. First is to see how good we can achieve our target, which we have set ourselves for the 3 quarters, for the 3 districts. And the second target is how we can make it more effective, the outcome, because let's say more regions are taken into account. How we do it, we have defined 5 areas of intervention. So we make ecological analysis, social analysis, and economical analysis. And what's very, very interesting in that is that there is not only one direction of impact. So if you have a specific social group, you have specific economic targets, and you can just apply or achieve specific ecological results. So, and there are different loops in that, and this is very interesting to see. What we develop also are, we check if the standards we have are good for energy and resource efficient planning, and if we need more regulations or fundings and stuff like that to bring the people to a more ecological and more economical plannings. So there are different correlations between that, and it's quite interesting to apply. This is just now a view on the student work for one district Essen, and we see that we have a lot of interventions in mind, which we can kind of imagine. It is linked to different districts, different functions, different energy movements between different areas, and of course mobility and new ways of water consumption and energy consumption are taken into account. The analysis is always carried out on district level and on building level. So what we see here, for example, if we are thinking about rainwater can be used for different functions in the building. And on the other side, we have to take care that we just have a lot of green areas, that the water is, we can use this. This is just an example about a facade planning. So the building always interact with the different sites, and we also go there in detail and think about, with the students together, and think about what would be a most appropriate way for a different function at the specific facade and orientation. And I think this is my last picture, just also for the quarter Essen, and it just shows that at the end, the human being is in the middle. And we always have to make sure that the people, or a lot of people, are interested in the plannings we develop for the next years. All right. Thank you very much.
Thank you very much, Elisabeth. And now into the Q&A. To both of you, what are the major challenges of scaling a pilot project or microgrid to widespread real-life applications? Starting with you, Ursula.
Well, I mean, in the end, you need to convince quite a diverse set of stakeholders to build it. So because it doesn't seem to happen by itself. So I think it depends a lot on the governance structures and who is behind driving that change. And I mean, here in Canada, North American context, it's much more driven by private investors, I would say, so which don't see and it's not, that doesn't make it easy because electricity is very cheap. So there's a few boundary conditions where I think change will only come for the small local renewable integration if there's a strong will of a municipality to do so, or of citizen groups, sort of maybe more unusual stakeholders that drives the process. I think that's really key to get these projects going.
Yeah, I would say the same at the first instance, and then I just can add that I think we have to come rid of the thing that we think we build it as we have done it in the last years. We have to be open to new ways of project groups and new ways of planning, integrated planning with a lot of synergy, and just we can achieve if we have interdisciplinary project teams. And the facilities management is taken into account at a very, very initial phase, and the users' demand is prioritized, is taken into account, and that's something like that, and not to think that a normal office building would solve all the problems we have.
And Ursula, can we only decarbonise with really fundamental changes to a city or region, or can we implement certain measures or technologies that still make a significant change?
I mean, I think we have all the technologies. We know basically what needs to be done, and I don't think we need sort of breakthroughs in technologies. I think it's all out there. So in that sense, I think it can be incremental, but the speed needs to be increased. The speed of transformation needs to be increased, and I think that again we probably need both bottom-up demand, and that comes from people wanting to take action against climate change. So that needs to come bottom up, but at the same time, if the government doesn't change regulations and incentives, it won't happen fast enough. So, but the pressure, I guess, will come from the people, but so I think there's still hope to speed up. I mean, I think everybody's now realizing the emergency situation, and I'm still reasonably optimistic that we can speed up the change. I mean, both in going large scale for renewables, which will solve some of the problems. But I agree with Elisabeth. The grid infrastructure is not set up to electrify everything and then say the renewables will solve the problem. No, we have a pretty limited grid infrastructure, and unless we bring in efficiency, we don't have. We would need to build an entire new infrastructure, and that's very, very costly. So I think this combination of efficiency to make possible electrification of transport is really key to the process. And that's not much discussed, actually. I mean, here at least.
Elisabeth, do you think we can make change fast enough?
Well, I think at the universities, we have a lot of ideas how to optimize the water consumption, the energy consumption, the resource management, how to digital plan, a lot of complex buildings. But the big problem is we haven't implemented it in the reality right now. And I'm a little bit afraid that if we don't push it from the bottom, from all the practical projects, what we're doing right now, if we don't push it, I think those innovations will stay at the universities for the next 5 or 10 years. I'm a little bit afraid of that. And this is actually what drives me to bring together the real estate industry and demand, which we have every day in every city, with different innovations from the universities. So,
And on that, we've talked a lot today about increasing integration and synergies between different sectors. How do you think microgrids can link with the mobility sector?
Well, I mean, the mobility sector, once it's starting to electrify, of course, is directly linked to the infrastructure, and it will pose a major challenge to the infrastructure because these loads were never planned for. That was exactly my argument of saying the mobility sector will add so much load to a low voltage distribution grid in the cities that either we upgrade the infrastructure at very high cost, or we reduce demand from the other sectors like the buildings. And I think that's a process that is starting to take place now, to say we need to liberate capacities to be able to electrify transport, and it will be a challenge. And that's why we also need these integrated mobility concepts, that we don't just electrify and stay with the cars as we have them now, this sort of private car transit. And here SUVs are even much more widespread than in Germany. So everybody has an SUV, and they all say, well, we need that for the Canadian winter. But so that needs to change as well. I mean, the whole mobility concept needs to change, and towards much more public transport and walkable cities. And then we need to integrate with the other consumers, so that we don't need to expand the existing infrastructure too much.
Elisabeth, any final words on these challenges?
Regarding the German context, I think we have a difference between the acceptance for new mobility concepts and the acceptance for new models of living and collaboration, co-living, something like that. We are used to share bicycle and cars and other vehicles. That is not a problem for us here in Germany, I would say. We are quite open for that. But in this situation, when I say to a user, well, I reduce your space for 20 square meters and you get an additional shared room on the ground floor or something like that, we are not that far. And I hope that this ideas from the mobility sector becomes also more attractive and more integrated into the construction industry.
That brings us to the end of the session today. Thank you both so much for giving us some insights into the projects that you're working on. I think we can all take away some really interesting information from that. Thank you both very much for taking the time.
All right.
Thank you, Greta.